Welcome, everybody, to another edition of Cosmos with Cosmos. As always, I'm Mike.
I'm Liz.
And Brandon is on assignment.
He's on assignment. We've sent him out into the world to discover new and exciting discoveries in the astronomy worlds.
Or to just install the planetarium.
Or just working in Arkansas for like a week.
You know that I saw that if you mispronounce it, it is illegal in that state.
To mispronounce Arkansas is Arkansas?
Yeah.
Because that's my favorite way to say it is Arkansas.
It is illegal to mispronounce Arkansas.
Oh, now I want to go and I just want to say it to everybody all the time.
Just yell it. Just go in front of like a police.
And then I want to be like, we're not in Arkansas anymore.
All right. Well, we already broke down. Show's already broke down.
It's already over. We're already in the hangover by now, I guess.
All right. So before we get started, why don't we just kind of talk about the rules, and then we'll get into drinks, and we'll see if anybody can figure out what we're talking about today.
Oh, so you're not even going to give them like the theme,
No.
even though they might have seen it on social media.
I'm sure they
what
did.
The theme is. So.
I know they completely have. Yes, Brandon is taking the ring back
That's his
to
assignment.
a volcano.
That's his assignment.
What we talked about Mordor last night.
Oh, it was Mount Doom. Mount Doom beer? No.
Hot sauce.
Hot sauce. We were watching Hot Wings on YouTube.
Hot ones.
Hot ones with the hot wings, and we're like, oh, there should be a Mount Doom hot sauce. That'd be pretty cool.
And there isn't one, so whoever is enterprising and wants to sink some money into it, go for it.
Okay, we haven't started the rules yet, so.
Yeah, so no drinking.
Doesn't count.
All right, so rules are if dog barks, take a drink. If there is a Star Wars reference, take a drink. And if there's a Lord of the Rings reference, take a drink, which we had not started yet. Yeah. So now if we had brought up Mount Doom's hot sauce, then we could take a drink.
Then we could take a drink, yeah.
Yes, but also follow us on all the things, Twitter, which is Drinking Cosmos, right? All right, cool. Yeah. And then everything else is Cosmos. So follow us on Instagram and like us wherever you get your podcast, and tell your friends and tell your neighbors and tell your enemies and all that kind of stuff. That way people can listen to us and learn about the astronomical world, the universe.
Wonders of the universe.
Wonders of the universe. All right, so why don't we get into what we're drinking? Liz, what are you drinking?
I am drinking a Reflector, and it is amaretto, vodka, cran pineapple juice.
Yep.
And
orange juice.
Oh, and orange juice.
Yes, it's a take on the Cranberry Kiss.
Amaretto cranberry kiss.
Amaretto cranberry kiss, which typically has rum and amaretto in it, but we're more vodka fans, and so we do vodka.
Yeah. What were we? Oh, we made a rum punch yesterday and uses dark rum, and I found that I'm not the biggest fan of dark rum. So
yes, and so what did you say?
I said Reflector.
Oh, mine's Refractor. Okay, so. All right, so my drink is Refractor, and it's the same thing.
They're two drinks of the same coin, or in this episode, two types of telescopes.
Two types of telescopes. We're talking about telescopes today.
Talking about what you can see with two small pieces of glass, even though my drink involves mirrors.
Yes, or a piece of glass and a mirror. So either way.
Yes.
Either way. But let's see. What is Jack drinking today?
Okay, so Jack has a lingonberry and mint iced tea, which sounds.
Somebody went to IKEA.
It sounds. His sister has lingonberries on the farm. I don't know if I've seen a lingonberry in the wild. I don't even know what a lingonberry is, other than IKEA.
It could roll into this house, and we wouldn't know. Leia would eat it, but
it sounds delicious.
It does sound really good.
And then Katie has a hazy sunrise, which is a glass of pink wine. That sounds good.
Oh, nice.
I like that.
Nice.
Cool.
All right, so let's talk about telescopes. You know, I was thinking about this. We didn't have a conflab on this. Yeah, I worked it in.
Conflab. We have a conflab.
Yeah, we've been watching Glow Up.
Watching Glow Up on Netflix.
I think we need a conflab. Anyway, so I was thinking that, okay, so telescopes show us the universe. But you know what? And I really want to drive this home for everybody. Go ahead.
I would like to refine that statement. And I would say that telescopes allow us to see the universe.
Yes. But also, what I was wanting to do was say that you don't need a telescope to see the universe.
Oh yeah, you don't. Well,
you need dark skies
to to really see into the universe.
Yeah, so maybe telescopes allow you to see further.
Yes.
See deeper.
Yes. To peer. No, never mind. I was gonna be like to peer into the heart of darkness.
Yeah. But all you got to do is, I just want to say this at the beginning. All you have to do is just go out into your backyard and look up and enjoy the wonders of the universe. There's a lot you can see without the aid of a telescope. In the early evening sky, you have Mars. Mars is kind of diving down towards that western horizon with each passing night. But Mercury and Venus are in the west. Jupiter and Saturn are up all night. Of course, you can spot the moon as it makes its way around the Earth in its orbit over the course of a month. There's meteor showers. Here in August, we had the Perseid meteor shower. Yeah. I'm going to say that with confidence.
I don't know. I think it was Perseid.
It's Perseid. I think
Orionids are coming up, though, right? I don't remember. Maybe. I don't remember when all the meteor showers are.
There's a lot of things that you can see and enjoy without the aid of a telescope. Just go out into your backyard, look up into the night sky, and enjoy the wonders of the universe. And just, really and truly become one with the universe. So just going out into your backyard and looking up allows you really to be part of the universe. And in our everyday world, we got work. We're worrying about, how we're going to pay our mortgage. We really aren't worrying about that. But we have things that we worry about on a daily basis. And where we are in a video game. But
when really just be happy that you're in this nice safety bubble of the Earth, because really if you were really like out in like, well, I guess technically we're in the universe because we cannot be in the universe because we're a part of it, but like if you're around, it'll kill you real fast.
Yeah, the universe is actively trying to kill you.
It's really best to be a part of and observe from the safety of Earth's little bubble.
Yep. But if you do have a telescope, the telescope allows you to see further and to see amazing things through it. So maybe we talk about where did telescope come from? I mean, we know about it. We're used to them every day.
Most people know.
In fact, we have one in here with us right now.
Look at this. Whoa.
There are amazing observatories all around the world, down in Chile, big island of Hawaii. We even have telescopes that are floating around above the Earth. So,
and one that we're going to eventually launch 1 million miles from the Earth. So you even look deeper and see more shit.
Knock on wood.
Yeah, it's...
So we've come a long way with telescope technology, but it had to begin somewhere. So let's maybe talk about where it began.
Something I found interesting. So, I did a brief bit of research before we started this episode. And something that I found really interesting that I didn't know is that, first of all, just everybody knows what a telescope is, I'm sure, or, if you hear the word telescope, you can kind of picture in your head maybe something, and basically a telescope is sort of some tubing and then either glass and mirrors that, kind of capture light. A telescope is a light bucket, essentially. And the bigger the telescope, the more light it can collect, the more we can see because we see light. And I found it really interesting that lenses or objects that resemble lenses date back 4,000 years.
Wow. See, I didn't know that until you mentioned it.
Yeah, and it's not known like what they were used for or if they were used for optical purposes. That there's no real record left of that, but yeah, 4,000 years.
Yeah. That's a long time.
Yeah, it's pretty amazing. And so like the Greeks, they had studied optical properties, and they even used terms reflection and refraction, and observed like color and all this like cool shit way back thousands of years ago. But it wasn't until sort of the sort of Middle Ages. Well, not Middle Ages, but the scientific revolution.
Oh, 1600s?
Yeah, around the 1600s, early 1600s, and before that, when you get basically a telescope, sort of a telescope object that is created.
Yeah, that spyglass.
The spyglass, which Hans Lippershey, Hans.
Well, he's dead. Lippershey.
We'll say however we want to.
And the thing is like we all think of as Galileo as the inventor of the telescope. He wasn't. And a lot of historians and scientists actually give credit to Hans Lippershey.
Yeah.
But there was actually this other dude, and I can't remember his name, that was in the same town as Lippershey. And so they both made optical instruments. And so Lippershey is credited with the telescope. The other guy is credited with complex or compound microscope. And so one sees big, one sees small.
They're two sides of the same coin, basically.
Yeah. And so, but Lippershey actually put a patent in, and that's why he is considered the inventor of the telescope.
He never got that patent, though.
No, he didn't. It was declined.
They declined his patent.
They declined his patent, and the reason why was they said that this seems like it's really easily reproducible, and so really anybody can make it, and so they declined it that way. But a year later, Galileo Galilei heard of it. And he actually made his own.
And he made it better.
He made it better. So Lippershey's spyglass could magnify things like 3, 4, or 5 times, and that was it. But Galileo and his telescope, he could magnify things 20 times. And
is it 20 times, really?
20, 25 times, yeah.
Oh, okay.
And he was the first to... I use the term first loosely here. He was the first to turn it to the sky and actually write shit down. So, life lesson, write shit down. If you, just do it.
Document.
And so, Lippershey may have turned the telescope and looked at the moon and all this kind of stuff, but Galileo wrote it down. And
he recorded his observations.
What did he see? He saw mountains on the moon. Now, why is that significant? Well, the moon at the time they thought was this perfect celestial heavenly object, and so it didn't have mountains on it.
And if you think about it, like if you look at the moon, like if you go outside and look at the moon, if it's full moon, don't look at it for too long. It could still hurt your eyes.
Yeah.
Because it's reflecting sunlight. But if you look at the moon, it looks flat. I mean, you can see color variations, like the face in the moon, that sort of thing, but you really can't see, a lot of depth or texture. It does just look kind of just
flat, like a perfect object,
just a flat disc in the sky.
Yeah. And
it's not until that you get that magnification and get a close look that you look at it and you go, oh wow, holy shit,
it's got mountains, it's got craters, it's got valleys, and so these are all things that Galileo saw that were just unheard of or unthought of at the time, because it was a perfect heavenly body.
Yeah. Can I cut in a little bit with just a modern comparison?
Why ask if you can cut in?
Well, I don't know, because you might have been on a roll, and I know you don't like being interrupted, so I was just.
Go ahead.
Okay, just a modern comparison is Pluto. We were talking about Pluto the other day.
Well done. Yes.
And a coworker of mine, he's upper level, but anyway, a coworker of mine sent me an article about Pluto and Pluto's status as a planet, blah, 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 and the whole thing surrounding that. It was a very good, very well done article by The Atlantic, I think. So we started talking about Pluto, and so Pluto, it was discovered in 1930, and it just looked like a dot. And then we get Hubble, and it just looks like a dot, but a bigger dot.
A little more resolution, but not much.
I mean, you can see like some variations in color and shit, and it's like, oh, okay. But we get New Horizons spacecraft to fly by in 2015, getting that up close view, and you could see this world that was just full of just amazing texture
things.
and features and just activity
Big
happening
heart.
that you would
Big heart on
never assume would be there. And we couldn't resolve those features on Pluto until we had the right technology.
Right.
You know? And so you know, that's like the moon in the 1600s, this flat disc for all of human history up until that time, that it was just like, it's just a disc up there, okay, was finally being seen for this, you know, geologic world.
What it is,
you know, so, which is really amazing.
Yeah, so you use the word resolve, and it brings me to another of Galileo's discoveries. So Galileo turned to the Milky Way, and so the Milky Way is this hazy band of light across the sky. Mm-hmm. And really what it is these hundreds of thousands of billions, really, millions maybe, unresolved stars. And so it looks like this hazy band of light. And so he turned his telescope towards the Milky Way, and he found that the Milky Way was not a hazy band of light. He was able to resolve it a little bit better, and he saw stars. And so he was able to see the stars of the Milky Way for the first time. He was able to see the 4 large Galilean moons of Jupiter, Io, Europa, Ganymede, and Callisto. He saw the rings of Saturn. He wasn't sure what to make of those, but they
looked like ears.
They looked like ears.
They looked like ears on the planet.
They looked like ears, and so he was able to see the rings of Saturn. He saw Venus go through its phases.
Like the moon goes through phases.
Yes, Venus goes through phases. So Venus is closer to the sun than the Earth, and as it goes around the sun, it actually will go through phases. Sometimes it's a crescent phase, and sometimes it's gibbous. Mm-hmm. You never see the full phase of Venus. It's always gibbous, even when it's coming around on the far side. You're getting kind of close to a full phase, but regardless, it goes through phases, and he was able to, through those observations, really prove that the planets and the Earth, well, in particular the Earth, goes around the sun. Mm-hmm. And he was able to prove the heliocentric model. Old Copernicus.
Good old
Nicholas Copernicus. Who released his ideas on his deathbed.
And Galileo was the first to call his instrument a telescope. Yep. And that comes from Greek, where tele is far and scoping is to look or to see, or far seeing. So it
was a very Italian way of saying it.
Really? Scoping? I don't know. Yeah. Scoping?
Well, so by the way, so if you have a pair of binoculars at home, binoculars today are basically, I think they're a little stronger than what Galileo had in 1609. And then go ahead.
I was just going to say, I would hope so.
Yeah. And so telescopes have gotten, obviously, better. More powerful, bigger and better. These light buckets, as Liz called them, have gotten bigger and better over the decades and centuries since Galileo. Mm-hmm. And and improved upon Newton.
Newton was like, all right, I see your telescope and I'll raise you a better one.
Yes, I will instead of using, so basically telescopes will have a lens at the front end of the tube, mm-hmm. and then it has another lens at the back end of the tube.
Isn't it like it was like one was like one's like convex and one's like concave or something? I don't know.
Yeah,
I looked up actually how telescopes work.
Well, anyway.
Other than bring me the light. I take your light and I give you image.
I want to say it's 2 convex lenses.
So I was briefly reading through, and there's there's so many different types of telescopes, iterations of telescopes throughout the centuries. Yeah. In fact, there was one I was reading about, and I should have put it in the notes. It was called an aerial telescope.
What is that?
And it was like it got rid of the tube, and it was like And it was like something that was then suspended from like a pole or a tree. And then
Yeah, really
I
and
was
truly,
like, what?
really and truly, the only purpose of the tube is to block out extraneous light.
Yeah,
I mean, that's really this is
because
only purpose.
You're trying to just grab like a specific area of light.
And so, but Newton improved upon the telescope at the time and added a mirror to it. And so the light comes in, it hits the mirror. The mirror is curved. It's not a flat mirror like we're used to in our bathrooms. It's a curved mirror like maybe you'd find at a fun house at a fair or something like that. And but much better. It actually focuses the...
Doesn't make it all wobbly.
Focuses the light in much the same way that a lens would. And this actually became a game changer for telescopes because to make a lens, you need really high quality glass.
Yeah.
And then so
it makes a lot of it.
Well, yeah, if you want it really big, but also the downside to that is that that glass is heavy.
Yeah, yeah.
And so you basically with a glass, it has to be perfect. High quality glass, and the bigger it is, the heavier it is, and the more expensive it is, the bigger.
And you can really, you can only then build a telescope so big then.
Yeah.
Because you can't, once it gets too heavy, you can only go so far with using just glass.
Yeah, and so with a reflecting telescope, I was going to say refractor.
I know, you got to think about mirrors reflect. So a telescope with a mirror is a reflector.
With a reflecting telescope, it doesn't matter the quality of the glass. It could be shit glass. It doesn't matter because you're just going to paint silver on top of it or some sort of reflecting kind of, surface on top of it. And so you can make it much bigger and it's not as expensive. And so there's a reason why, you can get a reflecting telescope. Let's say you have a reflecting telescope that's 8 inches across and a refracting telescope that's 8 inches across. That refracting telescope is going to cost much, much more than the reflecting telescope because of the quality of that glass.
Yeah. Apparently, Jack likes her orange shorts. But if you have $4,000, you can buy a Stellina. My mom saw a program on it yesterday, and it links to your phone. Modern telescopes are, they can, for at home, if you want to, do some real good observing, they can be pretty pricey. They can be, a couple $1,000s or so to get a good this telescope right here. This is a Celestron 4-inch reflector, and it was a birthday gift, and I don't know how much it was, but I'm gonna guess it was maybe a couple $100s.
Yeah, a few hundred at least.
But even with this telescope, I could see the rings of Saturn through
really
it,
well,
and it was amazing. They looked beautiful. So you don't need to spend a whole lot of money. It just depends on your level of what you want to do, how far you want to take it. If you want to be doing some astrophotography and get some really deep space stuff, you could.
But then you also need for it to track. And so the telescope that we have here.
Oh yeah, it doesn't move along with the rotation of the Earth. So you have to keep moving it if you want to follow anything.
Yeah, so that really limits your photography, but they do have telescopes. If you're willing to shell out a little bit more money, you can get Schmidt-Cassegrain telescopes, which are these little short, stocky little telescopes, but are reflectors, and they're driven by motors, and so they can track the sky. And in fact, I think that you can get them now where they track the stars, but they also could track, say, at moon speed. So the moon actually moves at a slightly different speed than across the sky than the stars do. And so you're not going to take a really long exposure of the moon, though.
No.
But
no, there's all different kinds of telescopes out there. In fact, Brandon, he has a Dobsonian.
Which she won't bring up here for some reason.
But I mean, we've been to star parties, and there will be these Dobsonian telescopes that people bring out that are like, you need a ladder to climb up and look at it because they have to have such a long tube.
Yeah.
And in order to get a good, I don't know.
So with a Dobsonian telescope, you have the mirror at the bottom of the telescope, and that light comes in down the tube, hits that mirror at the bottom of the telescope, and then bounces up to a secondary mirror at the top of the telescope, and then goes out to the eyepiece. So the eyepiece is at the top, where the light actually comes into the telescope. And the longer, the better. The longer that focal length, the better. Also, the wider it is, the better as well, because you're able to collect more light. Remember, it's a light bucket. And
the longer, the better.
Yeah.
Thicker, the better.
When a Schmidt-Cassegrain telescope, the eyepiece is at the bottom. And so what happens is the light comes in, it hits the mirror at the bottom of the telescope, it bounces up to a secondary mirror at the top of the telescope, which then reflects it back down to the bottom where the eyepiece is. And so it's, there's all kinds of different telescopes. Yeah.
Thank you, Hans Lippershey.
I know, right?
And then thank you, Galileo, for going like, I could look at the sky with this.
Meanwhile, pretty much, I bet Lippershey is like, God, I got fucked over again. I looked at the moon. First, they don't get my patent. Now Galileo wins the... God, I should have written shit down.
And then, so you get these continual improvements upon this instrument. They're getting longer or wider, or what have you, until eventually someone goes, or multiple people probably went, you know what? The problem that we still have with using these telescopes here on Earth is that... even though we're in our safety bubble of the Earth's atmosphere that keeps us alive, the Earth's atmosphere actually isn't that great to look through because it bends light and distorts light, which causes an issue if you want to see something clearly or see something far away.
Right. So the atmosphere is turbulent.
Yeah, it's turbulent. And so like if you're looking at the stars and you've ever noticed the stars twinkling... Stars don't really twinkle. Unfortunately, they're not twinkly. That is an effect of our atmosphere bending that light. And so these large research telescopes that are used today, they're usually placed at high altitudes, where there's less atmosphere to look through. Also, the colder, the better.
There's a reason why they're located in Chile on top of mountains and Mauna Kea in Hawaii.
Tucson, Kitts Peak in Tucson.
Yep.
And that's because they're trying to eliminate those effects of our atmosphere distorting the images or hindering our ability to see. So then people were like, well, gosh, what do we do? How do we get past Earth's atmosphere? Literally go past Earth's atmosphere. And we started sending telescopes out into space.
Hubble, the Hubble Space Telescope, conceived of in the 1960s, launched in the 1990s. But the thing is with like some of these like with Mauna Kea and Kitt Peak and stuff like that, these modern telescopes is our computers have come such a long way that we're able to distort these mirrors now, and you're able to kind of compensate for the turbulence in the atmosphere a bit. And oh god, I can't remember what it's called, that process that they do, but it basically distorts the mirror in real time and kind of gets rid of a lot of that twinkling with stars and things like that, but it doesn't take it all the way, and so you really need to get above that atmosphere.
Like, if you ever, well, this might not be related, but I just kind of thought of it. Like when you're if you look at pictures of, say, like a galaxy, like another galaxy, or like the Hubble Deep Field or something, you'll see stars that have that cross appearance to them, you know, like, you know, if you draw a fancy star and it, you know, it's kind of, that is actually a telescopic effect of a star in our own galaxy that's, you know, just happens to be in the field of view.
Kind of like a lens flare.
It's like a lens flare, basically. And so that's an effect of, then you can know, like, oh, that's from the telescope that's causing it, that they were using.
Yeah, and actually, like, you know, some astronomers will, let's say they're taking a picture, like the Hubble Deep Field, for example. There are some foreground stars in the picture, and they know that those stars are in our galaxy.
Yeah.
Because you are getting that crosshair on it.
Yeah. Crosshair. That's.
So, I don't know if that's the right word.
I don't know. That seems good.
It's what I'm using. I'm going to stick with it. All right. So, maybe, what are some of the things that we have discovered with telescopes? So, when we go out into our own backyards, I mean, we mentioned a few things, like with...
the sun at the center of the solar system.
Yeah, with what Galileo was discovered. But what have astronomers discovered after that?
A lot of things.
A whole lot of shit.
I mean, one thing I read, and I didn't read too deeply into it, so I don't know how they did it or how it was used, but I'm sure maybe Fancy Physics Man over here will know.
Oh, probably not.
But was that telescopes allowed astronomers to basically determine the speed of light.
Oh, yeah. Romer with Jupiter. And so Romer... 1700s, I believe he was 1700s. He, so Newton comes up with his theory of gravity.
Apple bonk.
Apple bonk. Hey, moon. You know, we can figure out orbits and stuff like that. And so they had the orbits of the Galilean moons and things like that, and they had charts of when these moons were going to make an appearance, and Romer was looking at Jupiter.
Romer.
What's it?
Do you know?
R-O, and that O has a little line through it. M-E-R.
Okay.
And he noticed that the times weren't matching up with what was in the tables. Oh. And it had to do with the fact that sometimes Jupiter is closer to us and sometimes further away. And he was able to get a really... highly accurate speed of light measurement just by looking at the moons of Jupiter.
Wow, that's cool.
Yeah, and I mean, can you calculate this number, and we've compared. We've said this because it's one of our favorite planetarium shows, Horse and Buggy Days. That truly was the Horse and Buggy Days. And
that was the literal horse and buggy days.
Yeah, and I don't know how fast horses can run. I'm sure that I will get an answer from this really quick.
How fast can horses run?
Even though we, and so that was as fast as they could go, and to calculate something that was 186,000 miles per second, even though he didn't get that, I think it was different, but not by much. Had to have blown his mind. Yeah. How the fuck is this going that fast?
Yeah.
It's a speed, like, I can't even comprehend it.
No.
But you know, I think I can comprehend it better than he can.
Yeah, I mean, when was this?
In the early 1700s.
So this is just basically 100 years after.
Not even.
We were confirmed oh yeah, the sun is at the center of the solar system.
Oh yeah.
So.
Yeah. I mean.
Oh hey, the moon has mountains on it. That's and now it's light travels ridiculously fast. Thank you.
Yes,
Adam.
about 1 horsepower.
1 horsepower
is a measurement of work. So.
Actually, wait, weren't we watching something and it was horses actually do 11 horsepower?
Yeah.
1 horsepower is not actually.
I don't even.
It's not equivalent to how fast.
What the hell were you?
38 miles per hour. That's how fast a horse can go.
Wow.
Basically, and it's you can't turn away. Those derby horses going.
And but then they go. I don't know, once they're on the track, and then they gotta eat and drink because they're exhausted.
Yeah.
So you can't go 38 miles an hour for a lot. It's like the cheetah can go 60 miles an hour, but not for a long time.
No, it's not.
Um,
I like what my mom just said. Telescopes are myth debunkers.
yes, they are.
And they are. I mean, if you think about it, I mean, basically our idea of that's average. Okay, it's just the average horse speed. If you think about it, for basically, all of human history, it's like except for like the Greeks. Who were the first to kind of be like, let's kind of look at the world in a logical, more natural way and try to figure shit out without using the supernatural. But through a lot of our history and still today, people use the myths and just made up shit to explain the world around them when you have Galileo observe moons orbiting Jupiter and Venus going through phases. That was explicit proof, objective proof that the sun was at the center of the solar system. Like that myth that the earth was at the center, that religious dogma that the earth was at the center, then was blown away. And then the church got mad and Galileo was excommunicated until 1992 when they were finally like, all right, yeah, okay. We see your point.
Yeah, for any religious people that are listening, science is not out to disprove your religion. That's not the goal of science. The goal of science is to understand the universe in which we live and to be able to model and predict different things
in an objective and logical way.
Yes. And so it's not science's fault that your religion can't keep up.
Or be able to prove what you're spouting. Anyway, anyway.
Yeah. This is a very religious household.
We won't.
Religion of science, motherfuckers. I really should not say that because science is not a religion. So any of you right-wing people can jump off the cliff.
Wow. Okay. Anyway, telescopes.
Yeah. But we discovered a lot of things with the Hubble Space Telescope. Mm-hmm. The Hubble Space Telescope
Wait.
has rewritten.
Before we get to Hubble.
Yes.
Before we get to any of the space telescopes, let's take it back.
Okay.
To maybe Hubble himself.
Yes. Yeah. Good point.
And what Hubble discovered using a telescope.
Yeah, there's a lot of people between Galileo and Hubble. The Herschels, which I feel, I don't want to bring up Herschel because Brandon loves the Herschels.
Oh yeah, William and Carolyn Herschel.
Yeah,
Brandon loves them,
and
he would be he's so sad he's not here right now, being able to talk about them.
But maybe in a hangover. So, but in the 1920s, Edwin Hubble. There was a big debate, actually. Great debate.
The greatest debate.
Is it really
no,
though? But at the time, we could see all these little fuzzy little things out there. Little fuzzies. These little fuzzy nebulae. And the question was, are these nebulae part of the Milky Way? Or are they, quote unquote, island universes? All in upon themselves,
like Milky Ways,
like the Milky Way. And so, seriously, 100 years ago, we did not know that the Milky Way. The question was: is the Milky Way the only galaxy in the universe, or are there others out there? And so there was this great debate about it. But anyway, Hubble actually proved the answer. He proved it one way or another, and he was looking at these. Fuzzy little nebulae, and he was calculating their distance, and he was able to figure out that they are so far away from us that they are not in our galaxy at all. But not only that, he was able to prove Albert Einstein wrong. Yes. So
he proved the big Stein wrong.
He did.
That's why Albert's hair's all crazy.
Yeah, I know.
He was proven wrong. Is just like freaked out.
So in 1917, general theory of relativity is released upon the masses and for all to enjoy and love, because who doesn't love general relativity?
And just for anybody who's not familiar with general relativity, is that the E equals MC squared one, or is that
was special theory of relativity in 1905. This is General theory of relativity is a theory of gravity at its
Okay.
heart. And Einstein quickly realized that his theory of gravity would mean that the universe would implode in on itself.
Ooh, that's fun.
Yeah, and so he did not like the idea. I mean, if you look out into the universe, it looks static, right? It looks unchanging.
Yeah.
And so he
It doesn't change much in our puny little human lifetimes.
No, you're basically seeing the same stars that the ancient Egyptians saw.
Yeah.
And the Persians and all.
Yeah, just in slightly different spots, but.
Yep. And so Galileo included the cosmological constant, which was to make the universe static.
Mm-hmm.
He didn't like the idea of it expanding or imploding in on itself. Well, Hubble looked out into the universe, and not only did he prove that these distant nebulae were galaxies in and of themselves, but he also proved that they were moving away from us. So the cosmological constant was Einstein's greatest blunder, quote unquote.
Oh, buddy.
Yeah, he said it. It was his greatest blunder. But Hubble proved that the universe was expanding, which then led to the 1930s, the idea of the Big Bang.
Right, like what's causing this expansion?
Yeah, so Lemaitre, who was a Catholic priest, interestingly enough, came up with the idea of the Big Bang.
Wow.
Fast forward 70 years, people lose their shit over it. Yeah, so Hubble has rewritten, whether it is the man himself or the Space Telescope, has rewritten astronomy books in the 1920s and then 80 years later.
And all because, some dude was like, hey, let's attach two pieces of glass to a tube and see what we can see. I don't know, the telescope or spyglass, what have you, is probably like one of the most like simplest inventions. Like yes. it's not that complex at all. It's basically just, a few parts and pieces of shit thrown together.
You can make your own. You can buy kits and you can make your own.
Yeah.
And you can even polish your own. Well, if you wanted to do a mirror one, you can actually polish your own glass and make your own telescope.
That sounds like a lot.
Yeah, I couldn't do it.
I would see. I have, and this is not my phrase, at all. I know I don't take ownership of this phrase, but I have what's known as a too much gene. So I would just I would think it's okay, and then I'd be like, no, it could be better, and then I would just keep going until I just fucked it up.
Well, the good news is there's instruments you can use to tell you if it's just right.
Yes.
So,
which is what they, I'm sure, use under the football field at
University of Arizona.
University of Arizona. I was going to say Arizona State.
Yeah, no.
University of Arizona.
At the University of Arizona, beneath the football field, they actually have a mirror grinding facility, and they will grind their mirrors, and they ground the mirror, obviously for Kit Peak. I think they were also grounding mirrors for Mauna Kea. Were they involved in Hubble?
I don't know, but James Webb, they did the mirrors for James.
Oh, they did? Okay.
James Webb.
And what's also really cool is that with telescopes, you can actually set it up so that you have a telescope in Chile, you have a telescope in Hawaii.
You can link them together.
And say in Australia or whatever, and you can link them together, and you can, because of the way physics works and all that, you can make a telescope the size of the Earth.
That's interferometry, right?
Interferometry.
Yeah.
Yep.
Which is a genius. Which is
yes, yes.
It's absolutely amazing because like I said earlier, telescopes are a light bucket. So the bigger the telescope that you have, the more light you can collect, and that means that the better, the more resolved, the farther you can see. And it would be impossible, it would be impossible to make a telescope a single telescope as big as the Earth.
Right.
So by just linking these telescopes together to then look at the same portion of the sky and then resolve that data.
Yeah, you're able to...
I'm using the word resolve a lot. I think it's because I used it once, and then you were like, resolve, and I was like, I used the word correctly, so now I'm going to use it for everything.
Yeah, so... But, it's a good word, though. I mean, it's a perfect word, because...
it's what you are.
Because you're taking something that is blurry and making it in focus. You're resolving it. Mm-hmm. And so...
Except for when Hubble was first launched.
Yeah. But they put contact lenses on it, and they resolved that issue. Telescopes just are amazing things, and they have really changed the way that we see the universe and the way that we see ourselves in the universe. In Galileo's time, the question was, are we the center of the universe, which was what religious dogma said? Or do we go around the sun, which makes more sense? Is the moon a perfect celestial object, or is it imperfect like humanity? What's beyond Saturn? Saturn was the most distant planet that we knew of at the time. Mm-hmm. You go forward in time with bigger and better telescopes. The Herschels discovered Uranus.
Mm-hmm.
Lowell discovers Pluto. The Lowell Observatory discovers Pluto. Clyde Tombaugh
discovered Pluto.
Yeah.
But Percival Lowell...
looking for life on Mars.
Yeah.
Edwin Hubble, in California, discovering that the Milky Way was not alone. And not only is the Milky Way not alone, the universe is expanding. Mm-hmm. And then based on that data, a Catholic priest comes up with the Big Bang Theory. With telescopes, we're able to find planets and asteroids. In the 1970s, Vera Rubin, oh gosh, my favorite Vera Rubin.
I know.
Discovers proof that dark matter exists by looking at data from telescopes, looking at the speed in which stars go around the center of the galaxy. They were going faster than they should go.
I would like to amend my earlier statement of telescopes being how we see the universe. I would like to amend that statement to telescopes are how we can learn and understand the universe. Mm-hmm.
Exactly. I like that. I like that amending of your statement. In the 1990s, the Hubble Space Telescope completely rewrote everything, discovering dark energy. It discovered, it saw exoplanets. But there were exoplanets that were discovered in the 1980s. By the way,
you can thank space telescopes for your cell phone cameras and being able to take pictures of your food.
Yes, I know, right? for Instagram. Meanwhile, we were very guilty of that last night as we were taking pictures of our dinner. They really the simple idea of these two small pieces of glass, and how light interacts and magnifies these things has really fundamentally changed how we see ourselves in the universe and how the universe is. And I actually will put, to me, the printing press is the greatest invention ever. Because it allowed the dissemination, the larger dissemination of knowledge, and got rid of only rich people being able to understand and clerics being able to understand how to read and write.
Protestant Reformation.
Yep. However, the Galileo's little telescope, Lippershey's little spyglass, is probably right up there.
It's better than sliced bread. Because why does bread need to be sliced?
It just makes it easier to make sandwiches.
Yeah, well,
All right, so where you live, I bet you there is a public observatory that you can go look through telescopes. And even if there's not a public observatory, I guarantee you that there is a local astronomy club. Look them up, and those local astronomy clubs undoubtedly have observing nights. Go join them. These astronomy clubs are join them for their observing night. You can join them in the club if you like, but
like go to a star party. Go to
their star parties. And they are more than happy.
They get so excited.
They get so excited when you show up and you want to look through their telescope. And they are local astronomy clubs and planetarium folk are the true ambassadors to astronomy.
We love talking about space, people. And showing off what we know about space.
We do. It's a passion. And go join them. It's a great date night.
It's romantic under the stars.
Yeah, and so... Yeah, go look through a telescope.
Yeah.
And if you don't have a telescope, just go into your backyard. Become one with the universe. And just take a few moments. Look at the stars. Look at the planets. And I guarantee you it'll de-stress you. And it will just make you happy. You have any other thoughts on telescopes?
Telescopes are awesome. And to quote my mom, there's really no limit to what we can learn because of telescopes. They've really opened up our eyes and our minds and have allowed us to explore the universe in a way that we cannot physically do yet, or maybe ever. And so by doing that, I think even if people tend to get a little overwhelmed by the concept of the universe and thinking like, we're all alone, or we're so tiny that then everything's meaningless and we're nothing, right? But if you look at the imagery that we get of the universe and just how beautiful and full of just power, it is, and with all these new worlds that we've been able to discover because of our advancing technologies of telescopes. And telescopes now are not just mirrors and glass lenses. It's, there's radio telescopes. There's telescopes that use infrared and...
Thank you, Herschel.
And X-ray. You get Spitzer and Chandra. And so we can observe and see all these new and different things that we would never have been able to see or understand. And so it has really helped us to just evolve as a species and become more connected to our place in the universe and where we're at, and really thinking like, maybe we're not alone out there, and that there are other civilizations of beings that are also looking out.
Yes.
That are looking at the same shit we're looking at, observing the same
maybe
things.
Even looking at us.
Maybe looking at us. Maybe seeing dinosaurs here and going, wow, that's a crazy planet. Look at those fucking mean-ass dinosaurs chomping on everything. Look at all those clever girls running around.
Yeah, well done. Clever girl.
And then, then you can look through a microscope and you see a whole nother universe.
I know that we're
a part of, that makes us up even, and so it's just, it's just a fantastic thing that as that we have been able to figure out and put to use to expand our knowledge and just kind of try and just be better and make life better and just.
Yeah. And let me just kind of really piggyback onto this because a lot of people go, like you said, oh, I feel so small when I look at the universe. But you're able to figure shit out. You might be 6 feet tall, 5 to 6 feet tall. That's all you are, which makes you feel small compared to the size of Jupiter and stuff like that. However, what's between your ears, your brain, has allowed us to figure out, how stars work just by looking at the light from those stars. How planets go around stars. How comets. We're able to figure out, what's going on inside of a bacterium. We're able to understand quarks, things that we can't really see, except in these, the Large Hadron Collider, and things like that. And so don't ever feel small. Your brain is able to comprehend and understand so much about the universe. You don't have to understand the math. You really and truly do not need to understand the math. You understand the universe at a really fundamental level. And
you're just lucky to be a part of it. Let's be honest. The universe, it's a hostile place. It's
trying to kill you.
It's trying to kill you.
It's really trying to kill you.
So the fact that you get to be alive and get to be like, oh, look at that star, that's pretty amazing in itself, and you are sharing literal space
yes.
with all of that.
Yeah. And with that, I think we'll call it a show.
Yeah, I think that's good.
We'll call it a podcast. So thanks for joining us, everybody. We will see you in a couple of weeks, and we'll figure out what we're going to talk about.
But if you're hanging out with us now, stick around for the hangover.
Yeah, we got the hangover coming up. I haven't had that much to drink. I only had one drink.
Okay.
All right, so we'll see you in a bit, and stay safe, stay healthy, wear your mask, everybody.
Yes.
And if you're not vaccinated, get vaccinated.
Get fucking vaccinated.